Like last time in general, you want to avoid dividing both sides by a variable or even any expression that contains a variable. Why? You might accidentally divide by 0 if you do this, and you might not even notice. So instead, factor. So let's look at solving the equation x to the 7 halves equals x to the 1 half power. So instead of dividing by x to the 1 half on both sides, we'll subtract x to the 1 half on both sides so that you have a 0 on one side. This sounds like we need to start setting up the 0 product property. So we're going to have to factor the left side. You can factor an x to the 1 half. Now I know this 6 halves looks funny, but x to the 1 half, if you were to distribute x to the 1 half, you'd have x to the 1 half times x to the 6 halves, then minus x to the 1 half times 1. So let's talk about that first part. X to the 1 half times x to the 6 halves. When you multiply things with the same base, you would add the exponent, and 1 half plus 6 halves is 7 halves. Okay, now we can apply the 0 product property, so x to the 1 half equals 0, or what's in parentheses equals 0. We just simplified the 6 over 2 to be a 3. So x to the third minus 1 equals 0. Okay, that first equation, we didn't really do anything to both sides. Just wanted to remind you, you don't have to write it this way, but it might help. X to the 1 half can be rewritten as the square root of x. So root x equals 0, or on the other equation, add 1 to both sides, so x cubed is equal to 1. Now the first equation, you're going to have to square both sides, so x is equal to 0. On the second equation, you have to cube root both sides, so x is equal to the cube root of 1. The cube root of 1 is going to simplify to 1. So you end up with x equals 0 or x equals 1. So just to comment, we said it earlier, but I wanted it in the slides. We squared both sides of root x equals 0. For x cubed equals 1, you have to cube root both sides, and that does not create a plus or minus sign. Only square rooting both sides creates a plus or minus sign. Also, just some other comments that sometimes people try to do, like cube root of 1 doesn't become 1/3. I mean, cube root of 1 is really 1 to the 1/3 if you want to know where that 1/3 exists. But the point is cube root of 1 just simplifies to 1. If you take x to the 7 halves equals x to the 1 half, the equation at the top, and divide both sides by x to the 1 half, you're only going to end up with x cubed equals 1, and you'll only get the solution x equals 1, and you'll be missing the solution x equals 0. Now, we're going to take a moment to talk about a bewilderingly large equation, and we're not going to solve it right now, but I know there's a lot of stuff here, right? Absolute values and x to the fourth and x to the second, lots of things going on. But my question is really, would you rather solve this equation, this huge equation here, or would you rather solve the equation u squared plus 4u equals 21? And then afterwards solve this absolute value of m minus 4 over a 5, then minus a 9 equals negative 7. Right? Would you rather solve that one huge equation at the top or these two smaller equations? I think everybody prefers solving two smaller equations instead of one monstrous equation. Today, what we're going to do is introduce this method called substitution. It's going to be really tempting to ignore this new method just because you see another way to do the problem. Please don't do this. We will need this method of substitution to build up to solve larger problems like the one you see at the top of the slide. But if we don't try the method is going to be great. But if we don't try this method on smaller problems first, there's no way to just jump into this on the big problems. So